It's all about the base times the base. Yeah, what's written here, little number 2, what does it mean?
Hi everyone, this is Mrs. Kaufman here, and I'm excited to tell you about exponent operations. So remember last week when we reviewed basic exponent parts, and we have the base here in this picture, which is 8, and the exponent is the little number raised above. And that little number, the exponent, is going to tell us how many times the number or the base number is going to be multiplied by itself. One of the examples we looked at to demonstrate exponential notation was the magic coin given to Aladdin and Abu from the genie. So since Aladdin and Abu freed the genie, they were given a magical coin from the genie. And on the first day, they were given this $1 coin as a thanks, but it turned into 2 coins pretty quickly. On the second day, the 2 coins turned into 4 coins, and on the third day, the 4 coins turned into 8 coins. And this pattern continued for 28 days, as you can see on this animation here. So this is just a way to represent how to visualize exponential notation. So we also looked at a different type of magical coin that showed us that dividing by 2 repeatedly corresponds to multiplying by 1/2 repeatedly. So when this coin was picked up, it was a full-size coin, but then on the next day, only half of the coin was left. On the day after that, a quarter of the coin was left, and on the day after that, only an eighth of the coin remained. So this was a way to see how the coin was reduced exponentially, which was a little different when the previous coin was raised by an exponent of 2. So also we can see with this coin, even though it gets really tiny at the end and it looks like it might disappear completely, it's never going to disappear completely because it's just going to get much smaller. So when you're multiplying exponents of the same base, it's actually a pretty simple trick and something pretty easy to remember. So I'm going to show you the example of 2 to the power of 3 times 2 to the power of 5. And you can see 2 to the power of 3 is written out 2 times 2 times 2. So 2 being multiplied by itself 3 times, and 2 to the power of 5 is 2 being multiplied by itself 5 times. When you write that out, you can kind of see that you have 8 2's. And what happens with exponents when you're multiplying exponents with the same base, all you have to do is add those exponents. So 2 to the power of 3 times 2 to the power of 5 ends up being 2 to the power of 3 plus 5, which ends up being 2 to the power of 8. And if you multiply 2 by itself 8 times, you're going to get 256. This also works for a variable base, such as x to the power of 3 times x to the power of 4. So you can see 3 x's and 4 x's being multiplied together. And if we add those exponents, x to the power of 3 plus 4 ends up being x to the power of 7. So I'm also going to explain to you how it works to divide exponents. So when you're dividing 2 or more exponential expressions with the same base, it works very similarly to when you're multiplying exponents with the same base. So when you're trying to find a quotient, for example, x to the power of 5 divided by x to the power of 3, instead of with multiplying where you add the exponents, for dividing exponents, you're going to subtract them. You can see that x to the power of 5 is 5 x's written out, and divided by x to the power of 3 is 3 x's written underneath that. We can also see that if we eliminate 3 of the x's on the top and the bottom, we're going to be left with 2 x's on the top. And this also works to show that because 5 minus 3 is 2, and since we're subtracting, we have more x values on the top, that's why our variable exponent is going to be on the top. So x to the power of 5 divided by x to the power of 3 is x to the power of 2 because 5 minus 3 is 2. So remember, when you're multiplying exponents with the same base, all you have to do is add those exponent values. When you're dividing exponents with the same base, all you have to do is subtract the exponent values. Thank you guys for watching this video about exponent bases. I hope it helps remind you what to do when you have exponents with the same base with multiplying and dividing. Thank you!